Okay, let's start review. First, let's review the electric potential and electric field. There are several pointers that you might need to remember. First, equal potential or field line never cross. So you can never think of like the 3-volt equal potential line like cross with 2-volt equal potential line. What about the intersection? The intersection is either 2-volt or 3-volt, so it doesn't make any sense. The potential line is perpendicular to the field line. It will help you to draw how to draw the field line based on the potential line, or how to draw the potential line based on the field line, which I'm going to show you later. And the denser the field line is, the stronger of the field strength is. As you did on the lab 2, there's a question about it, so I'm pretty sure you know what it means. Basically, there's a dense part of the field. That's basically that's the part that has strongest field strength. And the field line is always perpendicular to the surface of the conductor. As we said, the surface of the conductor is equal potential. So the equal potential line is always perpendicular to the field line. So those two are actually in a way is interchangeable, because the equal potential line cover the surface of the conductor. And the last but not least, the electric field line going from the positive to negative, which means like the potential that the electric field coming from have a larger electric potential. So let's see, there's a 2-plate. In the center, there's a circle. Let's figure out how to draw a potential line and field line from there. So as we know that the field line is perpendicular to the surface of a conductor. So pretty much we can draw the field line from here. So this perpendicular all the way here. It's always perpendicular like that. Right? Makes sense? So the field line is always perpendicular. Also the surface. So the field line is perpendicular to the surface of the circle. Like that. Perpendicular and perpendicular. So just connect the dot. Just like and we know that the electric field is coming from positive to negative, which is this direction. Ooh, sorry. Like that. Now we try to figure out the potential line. Basically, all the potential line is perpendicular to the field line, like this. So just connect the dot. But remember, it never crosses. Those are different potentials, so they should never cross. Remember that. I'm not the best drawer, but looks about right. So there's our potential line and field line. So you can see that the electric field is going from a positive to negative. And also, the potential is of course here is higher than there, because the potential is from 0 going higher and higher all the way up. So like that is lower than less than that. That's less than that. That's less than this. This is less than that. So yeah. And also you can see that the denser the field line is, the stronger the field, the electric field will be. Like here. I should draw more lines here, because here should be the strongest place. Here. Pretty much like the sharper the end is, the curvature of the metal or the end is, the stronger the field is. Should be like this. Yeah. Keep those in mind, and hopefully that'll be helpful for the test.